Ratios 101. Send me an email at flynn_smith@mybps.us if you have any questions or would like to send me your work for feedback. Visit my YouTube channel for other videos related to ratios, proportions, and the number system. Today we're thinking about ratios, statistical formulas that incorporate ratios, and the number system and where ratios live in our number system. You may find it helpful to have your data collection cards, whether this is related to earlier in the year when you just noticed something about your life and created a Dear Data postcard, or if you did it for Finding Nemo or Finding Dory. And we'll also tie back to our number research projects from the beginning of the year so that you all can find a deeper connection to our number system, especially when it relates to ratios and the statistics that we are practicing. A ratio is a mathematical object that allows us to compare quantities. So when we're comparing quantities, we often do it to make sense of the world around us. Some examples of making sense of the world around us in measurements and measurements that lend themselves to ratio thinking really well is the Kelvin scale for temperature. Thinking about temperature, you are measuring the heat in the atmosphere, I suppose. And in the case of kelvins, 0 is true, meaning that 0 represents no heat, whereas 0 for Fahrenheit or Celsius doesn't represent no heat. It represents the freezing point of water. In science class, you're learning about the water cycle, and this image reminds me of water flow, especially thinking about groundwater moving into the ocean or an estuary or a river for water collection or storage on Earth. Thinking about how the water cycle could be measured using ratios. Ratios can also be thought of as rates or rates of change in the case of possibly the flow of water through a pipe system. Again, down here we have height and weight. These also have true zeros, which means 0 in inches literally means something that measures 0 inches, although it doesn't seem super relevant to measuring a human or weighing a human. Okay, so thinking about quantities, we use that word quantities as we define ratio. A ratio is a mathematical object that allows us to compare quantities. So if we have this word quantities in the definition, we want to make sure everyone agrees on what a quantity is. So quantity can be measured or counted. Counted is a frequency such as the number of students, the number of planets, the number of times a character in Finding Nemo says, oh, I forgot again. Those are counting moments, frequencies, whereas if a quantity is measured, it's continuous. That could have a part or a decimal. It's a rational number that's not whole anymore or has the potential to not be whole. Thinking about 1.5 people doesn't make sense. Thinking about 1.5 meters makes sense. Okay. Then comparison. So a ratio is a mathematical object that allows us to compare quantities. Comparison in mathematics is often noted with a colon, a division symbol, fraction bars, whether they're slanted or horizontal, and fractions can be improper or mixed numbers, or really in decimal form. They can be anything. Okay, so I'm going to end ratios here. What you will do with your corresponding worksheet is, let me zoom in. So write your names here, obviously. And in the notes here, I would like you to take some time to think about the quantities you could compare in each of the following examples. So my example for Kelvin in temperature would be comparing the degrees to the hours past. This could provide us with an average change in temperature. So noticing that a temperature probably is more of a curved graph, but you can get an average temperature change. So the curve of temperatures, I have students who already graphed this. I know students who graphed it for Jamaica's temperatures. But if we take just a look, something like this is what I was thinking of, is the fact that like through the seasons, it goes up and down, up and down, and up and down. But what we can do with the beauty of mathematics is identify one point on the line and then another point on the line. So these would ideally be like 2 different days. And then we could, I don't know if I can grab a different shape, but it doesn't look like it. And then we can draw a straight line connecting the two. I just did a rectangle. It's not working with the tools I have here, but thinking about drawing a straight line between 2 points, then here, I'll just use a pen. So this is day 1, this is day 50. It's a curved sort of decrease, but if I draw a straight line, that'll show me my average rate of change. Anyway, ratios can help us with that. Moving out of there and back to your notes. So temperature change maybe, or just, from morning to, well, what happened here? Nope, that's not what I want. Tomorrow we're anticipating really low temperatures. So what is the change in temperature throughout the day? When the sun is high, it'll increase. When the sun is gone, it'll decrease, etc. Okay. So then in the water cycle, the water flow, let's say a volume of water per, I don't know, cubic foot. If we're thinking about pipe systems, what's the volume of water? Well, how do you measure volume of water? Let's say, I don't know, gallons. I'm sure the metric system makes more sense in terms of like how we measure water, but I think we use gallons, liters, I suppose, liters per cubic meter, something like that. How much the capacity is of the water flow, or what is the speed of water exiting a pipe. So anytime you're thinking about the speed of something, that is going to be a rate of change. A rate of change is speed, meters per second, miles per hour. Okay, height, how much you grow over a year, your height your growth over time. Same thing with weight, growth over time, things like that. Okay. That would be the end of sort of page 1 of your student notes and how that corresponds to the presentation. Next video will help you make notes about connecting ratios to the statistical tools we're learning about and thinking about. Okay.